Matrices A and B commute if A times B is equal to B times A. Let matrix A be a 2 by 2 with rows 5, 1, 3, negative 2. And let matrix B also be a 2 by 2. Row 1 is 2, 0. Row 2 is 4, 3. Multiplying A times B, we have 5 times 2 plus 1 times 4. Top row, first column. Then we have second row times first column, 3 times 2 plus negative 2 times 4. Row 1, column 2, 5 times 0 plus 1 times 3. And finally, row 2 times column 2, 3 times 0 plus negative 2 times 3. Simplifying each entry, you get a 2 by 2 matrix, 14 and 3, negative 2, negative 6. If you were to reverse the order and put matrix B first, followed by matrix A, and I'm just going to set matrix A over here so we can visually see the multiplication. Please use your calculators freely on multiplying, or any operation for that matter. It's much faster and you don't have to reinvent the wheel. Okay, so for the second product, B times A, row 1, column 1, 2 times 5 plus 0 times 3. Row 2, column 1, 4 times 5 plus 3 times 3. Row 1 times column 2, 2 times 1, 0 times negative 2. All the steps are given down here. And then finally, row 2, column 2, 4 times 1 plus 3 times negative 2. Simplifying all 4 parts, you get a 2 by 2 matrix, 10, 2 on the first row, second row, 29, negative 2. Since these two matrices are not equal, A and B do not commute. A couple of notes at the bottom of the page. Matrix A to a numerical power like a 2 or a 3, we have that many, you make sure that matches. So if that's squared, it's A times A. If that's cube, it's A times A times A, and so forth. And you would carry out the multiplication. You would take that matrix, you would raise it to whatever numerical power is given, and you'd want to do this on your calculator so it would make life a lot easier. A to the 0 power is defined as an identity matrix, which contains all ones on the main diagonal, zeros everywhere else. The number of ones on the main diagonal will be a subscript of I. So I sub 3 would be a 3 by 3 matrix with 3 ones on the main diagonal, zeros everywhere else. If you're given an m by n matrix A, the transpose of A is the n by m matrix A, and it looks like a power of t. That's notation for matrix A transpose, whose columns are formed by the rows of A. So long story short, row 1 becomes column 1, row 2 becomes column 2. Matrix operations of sums and scalar multiplication. We're going to let matrix A be this 2 by 3 matrix. Matrix B is also a 2 by 3 matrix. And matrix C is a 2 by 2. I purposefully made this a different size. When adding or subtracting, the matrices must be the same size, and you either add or subtract the same entries for each matrix. If we were to add A and B, we make sure they're the same size. Once we know they are, row 1, column 1, each entry So like the top row in the middle would be added to the top row in the middle of the other one. All the in-between steps are shown. Excuse me, y'all. If scalar multiplication is sprinkled in, do it first. 2 times matrix A, you would double each entry, so 8, -2, 0, 6, 10, and 4. Take care of the scalar multiplication first. Then you can subtract, and again, it's based on position. Upper left minus upper left, lower left minus lower left, and then you would put your totals over here. Adding and subtracting, the size of the matrix will remain the same as the original matrices that are added or subtracted. If your matrices don't have the same size, like A is a 2 by 3, C is a 2 by 2, those can't be added or subtracted because they have different dimensions. They're a different size. Multiplication, they're not required to have the exact same size, but what they are required to have is the columns of the first one must equal the rows of the second one. So if you write down your dimensions, like matrix A is a 2 by 3, matrix B is a 3 by 1, make sure your inside numbers match. If they do, then you can carry out the multiplication, and your answer will be the size of the outside numbers, 2 by 1. And of course, I recommend putting A and B, editing those in your calculator, and just letting it take care of the grunt work. An n by n matrix A is invertible if there's an n by n matrix C such that A times C equals C times A, and they both equal an identity matrix of an appropriate size. If that's the case, matrix C is the inverse of A. A matrix that is not invertible is called a singular matrix. An invertible matrix is called a non-singular matrix. That's just some vocab. Given matrix A and matrix C, we're going to ask or determine if C is the inverse of A. Multiplying straight through, A times C, row 1, column 1, 2 times -7 plus 5 times 3. That gives us 1. Row 1, column 2, 2 times -5 plus 5 times 2, that makes 0. And if you finish the multiplication, again, all the intermediate steps are given, you will get an identity matrix of size 2. If you multiply the other order and put matrix C in front, multiply it by A, and you carry that multiplication out, you will also get an identity matrix that's a 2 by 2. Since A times C and C times A give you the identity matrix, you can make the claim C is the inverse of A.